Hello everyone, it's September the 9th. We didn't do very well yesterday, so let's hope today we can have better luck. And my laptop is just getting worse and worse by the day. Anyway, let's take a look. Arithmetic slices. Number 2. Come on. Alright, subsequence. Given an array, nums, return the number of all the arithmetic subsequences of nums. A sequence of nums is called arithmetic if it consists of at least 3 elements and if the difference between any 2 consecutive elements is the same. For example, this, and this are arithmetic sequences because at least 3 elements and okay, I see it. It's minus 4. Minus 4 and minus 4, okay? This is not arithmetic because these two has difference of 0 and these are difference of 1. Difference between any 2 consecutive values is the same. A subsequence can be formed by removing some elements. For example, this is the subsequence of this, okay? Generated so that the answer fits in 32-bit integer. Okay, given this, we want to return all the number of all the arithmetic sequences, subsequences of nums. So all arithmetic subsequence, we start 246, 468, 6810. Oh, the entire thing is 2, 4, 6, 8, 10. 2, 6, 10. Oh, wow. See. Any subsequence is arithmetic. That's true. 1000. Okay. Yeah, I'm never a fan of this type of question. But we'll handle it. Alright, so we have an array of nums. It doesn't say if it's sorted or not. I'm pretty sure sorting it is very important. Let's say we sort it. Let's just go for this one. 2, 4, 6, 8, 10. Right? Now, the entire thing, 2, 4, 6, 8, 10, is arithmetic. Right? So they gotta be yeah, so if we have a sequence, right, that is itself all arithmetic, then we can compute a total number. So total number will be 1, 2, 3, 4, 5. So 5 minus 3. 1, 2, 3, 5 minus 3 plus 1. That's the total number of 3, right? Triplets that can form. And total number of 4 we can form. So 5 minus 4 plus 1. And total number of 5 is 5 minus 5 plus 1. So basically, we have n, right? And then we have n minus 3 plus 1 plus n minus 4 plus 1 plus plus n minus n plus 1. So that will be n minus 2 plus n minus 3 plus plus n minus 1, right? So how many are we talking about? We have n minus 1 minus 2 plus 1. So we have n minus 2 terms. So the n times n minus 2 minus n minus 1 plus 2 times n minus 2 divided by 2. This gives us n plus 1, right? N squared minus n minus 2 divided by 2, and then n squared minus 2n minus this thing. So we raise it up, plus and plus, n squared minus 3n plus 2 divided by 2. So it's n minus 1 times n minus 2 divided by 2. So that's a total number can be formed if we have a sequence. You can try, like say, if n equals 3, n equals 3, result is 1. It's true. If n equals 5, which is this case, right? N equals 5. 1, 2, 3, 4, 5. No, let's look at this one. N equals 5. We're talking about consecutive, right? 5. So it'd be 5 minus 1 times 5 minus 2. That's 4 times 3 divided by 2. That's 6. That's 6. 6 comes from all this, right? Just no subsequence, just original. And then we have another one here, which is we remove the 2. And that is the difficult part. Okay? Yeah, that's fine. And for this, it's different. Right? Any subsequence. So we have the original and with no subsequence. And then we start to do subsequence. Basically means that we're going to remove things. So remove 1. Oh, hold on. How do we handle this one? The total number of subsequences. And then just the square, 2 to the n minus 1 power. Basically, we're saying this with 3, right? So any 2 from here, we can get this one. And any 2 from here, we can get this one. How does 16 come from? I have 7, I have remaining. So we need to get all kinds of 2, right? So get all kinds of 2s, and then get all kinds of 3s, all kinds of 4s. And then we get all kinds of 2. So with this 7, the same thing. So 7, 7, 7, 7, right? Is it 7, 7, 7, 7? That's 1. Subsequence. All subsequence. No, not like this. So all subsequence will be, you can remove, right? You can remove the first one. And remove the second one. Remove the third one. Remove the fourth one. Remove the fifth one. So that's 5. Remove. Now I can remove 2. 2 of them, right? Any 2. Any 2. So it's gonna be 5 choose 2, right? Yeah, we can remove any, but we cannot remove 3. So any 2 will be, I think it's 5 times 4 divided by 1 times 2. That will be 10. So 5 choose 1, plus 5 choose 0, plus 5 choose 1, plus 5 choose 2. That will be 16. Yes. That's when all subsequence. That's how you get all subsequence. Alright, hold on. I'll be back. So we figure out the test case, but how are we going to go about this? How are we going to go about this? So I have an array, right? I have an array and sort it. So I have the smallest value, right? And then I look to the next one. I say, what's the difference? And then this could be a subsequence. And then the next value, we say we have a difference. And then we try to see if we can build a subsequence out of it. Okay? So we'll try for the next one. If it exists, we take it. And then we'll build the next one, we take it. So we get a sequence. Right? We get a sequence. Something, something, something. And then we can use the formula to compute how many total number, right, can get out of this sequence. That's fine. And once we find this, now we go back to the front. We say 2 and then go to the next one, right? And try to see if we can build another sequence. So we go 2 to all the other ones, like the subsequence that involve 2. We'll try to find all of them. And once we get there, right, then we're done with 2. Now we move on to 4. And move on to the next one, right, 4. Now how do we avoid repeating ourselves? Because if we do 2, 4, 6, 8, 10, right? So that's the first one we get out. And we compute everything, which includes everything else. And now we are at 4. How do we know 4, 6, 8 has already been handled? 4, 6, 8 has already been handled. Interesting problem. So once we got something, right, from the start, we go a sequence. And as we're adding more sequence, then we shall know that it has been checked, right? Let's say we have a array, a DP array, right? So let's say from a certain position, right? And then the next position has checked, or we have checked. Could be a key, right? A key. So like 1, 2, 4, right? So that's the first 2. Now we try to find the next one. We can do that. Yeah, we can do that by saying, okay, 6 in it. 6 is in it, right? So 6 is in it. Now we check 4, and then in the dictionary we say 4 has been checked, given 2. And then we're looking at next one, 6. So 6 has been checked, given 2, and 6 has been checked, given 4. Yeah, it has been checked, given 4. So when we look at 4, and we say, oh, look at 6, we already checked. I don't know, man. So we create this subsequence, right? And what we're trying to say is, if we go to the next value, we don't do it again. 2, I go for 4, it has not been checked. 6 not being checked, everything is not being checked, so we check everything. Right next, the adjacent. So like I said, if 2, 4, 6, right? So we say 4 is checked based on 2. 6 is checked based on 4, but 6 is not checked based on 2 because they are not adjacent, right? But 6 is checked based on 4. And we go 8. We say 8 is checked based on 6. 10 is checked based on 8. So we've done this. Next one, 2 will go to 6. It's not been checked before. And then it's a good. And then we go to 10. I say, okay, 10 is checked by 6. So we get that. That's good. Now 2 will go to 8. And find out, oh, we explode. So we drop. Now we'll go to 4. 4, 6, checked. So we don't do. 4, 8, no. So we check this. But then, boom, explode. So we don't do. And 6, 6, 8, checked. So we don't do. 6 and 10, we explode already, so no, don't do. And 8, we don't do 8 because we don't have enough, so we're done. So yeah, that's how we get this. Now, can we use for this? And position, 7, right? So we check position, this position we checked, and now we go this, so checked, this checked, right? So this will give us 6, right? We'll give us 6. It's fine. Now I go to here. Say, okay, check. Go here. Oh, dang. Then we go this one to this one, and we're gonna go here. Huh. Yeah, we can go this and this, and this and this. Just check again. It's fine. We just say checked, and this over here, checked. That's fine. So that's 4. Right? 4 will be 4 minus 1 is 3. Yeah, so it will be 3. And then this one goes here. Man, that's gonna take a while. O(n) squared. That's 1. Okay, so we'll go here. This and this we checked, so we don't do it again. This and this, no, haven't done it. So that's 1. And then go here. This and this we checked. This and this, no, it'll explode. That's it. No, that's not right. That's only 11. What has gone wrong? Isn't this just a... Oh, hold on. We cannot sort them. No, we cannot sort them. It has to be following the original order. Okay, no sorting. But why is this one not working? So we have 5, right? 5. We got a 6. And then that's 4. Right? And 4. We got 3. And then 3, we got 1. Yeah. And from here. And that's 4, already checked. Huh. It's not working for this one. Like I say, this has been checked. The distance is 0. But we have multiple things that we can try. No. No. I think this is a unique case when we have the same values. I think that is a unique case. Because other than this just means we can choose any, right? Anyone to add it. Yeah. So I say this and this difference is 0. So when we find, we find 3. So boom, we got 3. And then, right? And then basically means among the 3, we're going to take all of them, one of them, or 2 of them, right? Okay, so that's done. And then this and this do the same thing, and this and this do the same thing. Here, this and this, we cannot do because some of it have been done before. No, have not, because this one is not included. Yeah, it's starting from here. Right, this and this. Or whatever. Right, and then this and this. Whatever. So, okay, so what I was saying. What I was saying is can be focus on the first 2. That's C3 choose 0 plus C3 choose 1 plus C3 choose 2. Right? And then this and this will be C2 choose 0 plus C2 choose 1 plus C2 choose 2. No, I should take C choose 3. Right, and then this will be C1 choose 1. That's it. Go to the next one. Will be C2 choose 1, C2 choose 2, and C1 choose 1. Right, and then go here. That's just C1 choose 1. Okay, so total 1 plus 3 plus 3 times 2 plus 3 plus 2 plus 1 plus 1 plus 2 plus 1 plus 1 plus 1. Right? So it's 1, 2, 1, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16. Yep, that's 16. Maybe that's a better way. So we have 2, 4, 6, 8, 10. Let's say we'll look at 2, 4, right? 2, 4, so we need to find how many others are 6. Right? And boom, we have 1, so we got 1. C1 choose 1, right? Now we need to find, that's it. So now we go 2, 6. We need to find how many are 10, which is 1. And 2, 8. We explode. And we cannot do 2, 10, right? So that's it. That's it. That's all involving 2. Now we go to 4. 4, 6. 4, 6. How many are 8? That's 1. That's it. And 4, 8. Nothing. Explode. And that's it. 6, 6, 8. We got 1. Oh, hold on. That's only counting the triplets. That's only counting the triplets. That's counting if the 2 are the same, right? That's how we handle it, the 2 are the same. If the 2 are not the same, then so it's 2 different methods, right? So one method is we extend to find the longest sequence, longest subsequence of the current difference involving, let's say, the first value, and then we run the arithmetic, we compute, right? And that's it. And then we go, second one also extend. And as we extend, and we mark which one we have done, which one we have not done. That's fine. But if a consecutive pair is the same, we have a pair that's the same, should we handle those separately? Okay, we can handle them separately. That's fine, we can handle them separately. We might be able to handle them separately. So we do this trick, right? And if they're the same, we just escape. We do this trick for everybody, and then we handle the same things at the end. Okay, let's see if we can find a formula for the same. So basically it's a Cn, right? Choose 0, right? Plus Cn choose 1, plus Cn choose 2, plus da 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 da. Cn choose n minus 3. Yeah, so that's the formula, which Cn choose 0 is 1, is n, that's n times n minus 1 divided by 2. And then next one is n times n minus 1 times n minus 2 divided by 3, all the way to, oh, I don't know, man, probably is there a sum of combination? Is there like a formula for that? Say sum of combination series. It might. Evaluating sum of combination series. Come on, don't show me this. Oh my god. Nope. Let's just iterate through. It's only 1,000, so it's not too bad. Oh, but each one we have to calculate the combination. Ay. Does Python math has combination? Combination. It should. Yeah, I'm gonna just throw everything into a counter and try to figure out if any. Yeah, that will help. Yeah, I'll throw it into a counter, and then we try to build up the longest series that we can have. Yeah, math.com. I think we have. Read the documents. Huh. A lot of time is spent waiting. God. Oh, come right here. Return the number of ways to choose k items from n items without repetition and without order. Yeah, I think we can do that. All right, I'll give it a shot. I have some idea. I'm trying to see if this idea works. It will run O(n) squared. Wow, takes so long. All right, let me disable this thing. How do I preferences? Remove package. Yep, I'm gonna remove Anaconda from my Sublime. It just take way too long to handle. Did I do it? Well, I have a lot of clutter in there. This as well. Let's see if I have removed it. Yeah, I think we have removed it. Oh, why I still see? Try again. I think now we're good. I try to make this experience smoother. Alright, I should make the text editor a bit smoother. Alright, so the idea is first we need a counter. Alright, so from collections import counter. So counter equals counter nums. Okay, so that one is done. Next, we're gonna build up the sequence, right? Build up the sequence. So what I have is a memo. Right? Memo is going to be, what is memo going to be? Memo going to be the position that has been checked, right? The position. So memo is going to be a dictionary. I'm going to call it default dict. Right. So memo is going to be a default dict offset. Right. So it'll be easier for us to check. I mean, technically it can be just an array of array. Yeah, it's this position. This one has been checked. You know what? I think that would be a better option. Let's just say memo n equals line nums, and memo equals 0 times n for underscore in the range n, right? The memo is to check which one has been set. So now we're going to go for I and enumerate nums, right? So we're going to enumerate nums, and the second one for j in range I plus 1 all the way to n minus 1, right? N minus 1, because this is the last one we can hit. Right? Yeah, so this is n minus 1, so this is the last one we can hit. So j is in this, and we're going to go if memo ij, then continue, right? I mean, we have checked already. Otherwise, we're going to set memo ij, right, equals 1, so we set it, and then we're going to, starting from here, keep going on. Oh, that will be O(n) tripled. No, I think O(n) squared. The size equals 1, so including the first one, right? And then memo, so this one's checked, and then the diff equals nums j minus n, right? That's the diff. And then from this position, now we start to define. Oh, then the size should be here. Size is not here, size is here. Size is 1, and then this, right? Then for k in range j plus 1 all the way to n, right? And then for each one, when we hit, okay, so k will be starting from here, right? And then we say, no, that's not what we're trying to do. We need to find it directly. Like directly. No, that's not how we do. We want to find its index directly. How do we find its index directly? Okay, binary search. So instead of a counter, we can record its index, right? And every time, if it exists, then remove it's 2 pointers, right? That's the current pointer, and then we're gonna find the next pointer, and then this relationship needs to be we set a diff, we have the size. Now we need to see, actually the size is 2. Now I need to find if there's others exists. Okay. What if we have multiple that's the same? What are we gonna do? If we have multiple that's the same, we only need, oh man, that will be different, right? Let's say we have multiple 6. What are we going to do if we have multiple 6? Right, because more than 1 6. So 2, 4, so we find 6. There is 6, but we have, let's say, multiple 6, right? And so we find the first 6, and then we get some, and then we might have another 6. No. I don't feel that is the right way to go. Try it again. 2, 4, 6, 8, 10. Right? If we say we need to find 6, right? And then we have multiple 6. Okay, that's fine. How about we say size 4? Now, size 4 will require size 3 is fine. Size 4 we require to find an 8, right? And if we have multiple 6, and then we say the multiple 6 are scattered around, some are in front of 8, some are behind 8. How do we know? Good question. How do we know? Any two consecutively the same. Yeah, I can't even build, right? Because for each one, it will be a different. What the hell? Change your mind. Come on, change your mind. So, what if I say... What if I say I know the total number, and then I add one value? Okay, let's say I know the total number of a arithmetic sequence of this, right? And I add a new value. How will that change the dynamic? Well, if I already know total number, and I add a value, right? And then if we want anything more, then we have to include this value, right? Then we need to know how can we include this value. So we compare to every single one, except the first one. So compare to every single one and see if there exists another value in it. If it exists, then this one can be expanded. But how? How can it be expanded? I mean, simple like this, we have, let's say 2, 4, 6, right? 2, 4, 6, we got it. Now 8 comes in, and we can compare 8 to 6, that's 2, difference is 2. What if we also record the total number for each difference? Let's just say magically we have the difference is 1, difference 0, we have a value, 1 value, 2 value, whatever, right? We have a total number. And now we come a new value, and we compare. And if the difference is more than the ones we have, hold on. We need 2. Let's say we have 2. Right? 1 is the things we already formed, at least 3 or more. The other will be difference, and then we'll have 2. Right? Differences only have two values. Okay, now what do? Now we say if the difference is 2, then we add one more, right? But still, like even if I know the total number of different, I don't know the sequence. The sequence. If I can find the sequence, let's say I can find the sequence. I have the sequence. Let's say the sequence is starting from 2 and with 6, right? And then with differences 2. That's what I have. Right? And then I have another one starting with something and with something. And now a new value comes in, and then we compare this value to one of the other values. Now we compare the value and it give us 2. Right? The difference is 2. So it can be added to anything that ends with that value that we compared to. Okay. Then we can expand, and those sequences can be expanded. Okay, so let's say it can be like this, right? And then we what? Go through each one. Difference is 2, right? And then the end is going to be, let's say, 6. No, because we're going to change the end. The key will be changed. Yeah, we just have range and range and range. Like, how can we obtain the range in the fastest way possible? We can define all the range that with, let's say, 6 as the end, and then all of them will be changed to 8, right? That's what it is. All of them will be changed to 8. And then we move on to the next one. Then we're comparing every single one. That's our O(n) squared. But we have to also iterate through this list to build the longest that we can build. I mean, worst case will be O(n) tripled. Unless we can do this. Yeah, but each value has they're starting with something, we end with this, right? And the end, now I need to expand. Let's just give it a shot. I'm gonna try. So we start with the first 2. We have to. So 2, 4. So we get difference is 2. So that's what we start with. Now we look at the third value. So 2, 4. So what we start with is an empty dictionary and value of 2. So we have a set. a set 2. Oh, that one has to be a dictionary as well. 2 with 2 and 4. So distance is 2. All right. That's not ready. It's not ready yet. Potential. This is good. Right. And then we start from the third value. Coming 6 comes in, right? So 6, we're gonna minus 4 is 2. So we look into 2. Right? We'll look into 2, and then the 2, currently the ending, if the ending is 4, right? So that's what we compare to. So ending is 4, then we are taking it out and pushing it in to the good. So we have 2, 6. How do we take it out? Oh, why? We can just hold it in one dictionary. That's fine. Just hold it in one dictionary. Distance 2, we have 2, 4, right? And then we'll iterate that, and then all the 4s will be changed to 6. Yeah, that's good. And then that's it. Now 8 comes in, right? 8 comes in. 8 minus 6 is 2, so we're going there. All the 6 will be turned into 8. Okay, all the 6 will be turned into 8. And then 8 minus 4 is 4. Oh, 6 minus 2, we have to do that. 6 minus 2 is 4. So we go 4, 2, 6, right? Now, 8 minus 4 is 4. And then we're going to 4. And we need to search if anything ends with 4. And nothing ends with 4. If nothing ends with 4, then that is the start. Right, that is start. So we add 4, 8. Next one, 10 comes in. Right, 10 minus 8 is 2, so 2, all the 8 switch to 10. And then 10 minus 6 is 4, so all the 6 switch to 10. And 10 minus 4 is 6. And 6, all the 6 will be 4 and 10. Right? And that's it. So when we come out, go through each difference, go to 2. We have 2, 10. That gives us 10 minus 2 is 8. Divided by 2 plus 1, so they gave us 5 values. So we go the formula, 5 minus 1, so that gives us 3 times, that's why it's 6, right? And then go to 4, 2, 10. 10 minus 2 is 8, divided by 4 plus 1, so that's 1. For 8, only have 2 values, so we discard. And then 6, we only have 2 values discard, so total is 7. Okay. Can we solve 7, 7, 7 based on this? Well, to solve 7, 7, so we have 7, 7, and then will be 0, right? 0 with 7 and 7 to start. And then the new one comes in. New one comes in, that's 7. No, that will be too complicated. And we hold, like the same value still we're gonna hold, right? We're gonna hold. We do them by themselves. Right, what if we have repeated value, like 2, 4, 6, 6, 6, 2, 4, 6, 8, 10, 6, like that. How would you handle that? So we do 2, 4, 6, 8, 10, that's good. Now we have an extra 6. and 6 and 10, that's -4. So we have a -4 now, right? And then 6 and 8, we have -2. 6, 6, we have a 0, but 0 we skip. We don't worry about a 0. And 6 and 4, that's a 2. What do we do? Shoot. Well, like in this method, it will be not. I don't know. Are you saying we're gonna keep 2, 4? We cannot keep it because we're extending. We're trying to extend as much as we can. So we cannot keep it. We have to replace with new ones. Bless you. New one comes in. That means we can remove everything that's in between, right? So we don't have to, those we can ignore, right? Ignore. That will be the same value as we computed for this one. But what if we have an 8 again? Thought about that? We have 8 again. Then what? Say we have 8 in the past. Okay, we have 8 in the past. So everything will be the same. But then we have this. Yeah, seriously. Like if we get wow, it's gonna be like 2 days in a row. I can't solve this. Holy moly. Yeah, if I do 6 and 8 again, that's a different story. Twelve. Answer is 12. So basically we have 2, 4, 6, 8. Right? That's 4. 4 will give us 3. Right? That will give us 3. And 2, 4, 6. 2. Oh, how was 4, 6, 8? That's 4. Oh, I can't even count 12. That's 3. Oh, we have also 4, 6, 8. Or 4, 6, 8. 4, 6, 8. And 4, 6, 8. It's 12. Oh. Right, 6 is here. Well, I mean, this scheme is not working because I already extended. It's 2 to 10. Right, that's everything. It's 2 to 10. I cannot know again. And I feel like it has to be dynamic programming, right? It has to be. Just I haven't found the way to approach it. I like the idea of something new is added. Something new is added, and then the question is how this new thing can get incorporated into the previous. Right? And by incorporating, we're saying, say 6 is a 2, then we need to find something that's already done with 2. I'm recording all the sequences to have. That's way too much work. It's way too much work. It's like all the sequence that index, and like 8 to 6, right? That's 2. So we need to find all the sequence that ends with 4. All the sequence that ends with 4. How many are there? And we have 1. Right? Sequence ends with 4. Now not only ends with 4, but with the difference is 2, ends with 4. Then we can compute a new thing that involving this and this. Now we go this to this to 6 again. So we find everything that ends with 4. Everything that ends at a certain value with a certain difference. Okay, that's a new idea. So we're gonna go with 2, 4, and then we'll say the sequence ends with 2. What's the difference? Difference is 0, right? Difference is 0. So we say start with 2 will be difference is 0. Now sequence end at 2, right? And then difference is 0, current length is 1. Now 4 comes in. Sequence end at 4, right? Difference is 0, length is 1. And then 4 minus 2 is 2, right? So we say, okay, then if we want a longer sequence, two. So in order to find how long the sequence is with 2, we need to search for ending at 0, right? Ending at 0, and then it's nothing ending at 0, which means the length is 0. So the sequence length ending at 4 with differences 2 is going to be myself plus this, right? Sequence ending at 2 with difference is 0. Sequence ending at 2 with difference is 2. That's 1. No, wait. The difference is... Hold on. We don't look at this one, right? We don't look at this one. Because this one has no idea of the difference. This one doesn't include. So we just say, we're looking at 4, 2, right? So the current sequence length is 2, right? Sequence length is 2. And we say, how many more do we have? So we say, we need to look for 0. 0 out there, so it's actually 2. So ending at 4, right, with the distance, with the difference, now 6. Ending at 6. Ending at 6. Again, difference is 0. We have length 1. We go 6 minus 4 is 2, right? So we need to look for 2. Right, 6 minus 4 is 2. So we just know the difference. Now that's because in this case, I can check 4, right? So 6 minus 4 is 2. So I want to say difference is 2. So we go to sequence ending at 4, and difference is 2. How long? And then sequence ending at 4, difference is 2. The length is 2. So for 6, sequence ending at 6, difference is 2 is going to be 3. Length is going to be 3. And then this is 4. And we'll look at 2. Sequence ending at 2, difference is 4, is a 0. So sequence ending at 6, difference is 4, is going to be 2, because we start at 6 and 2. Next one, 8. Again, 0, 1. So every sequence ending at 8 with difference is 2 is going to be 2. Looking at sequence ending at 6, difference is 2. That's 3, so that's going to be 4. All right? And then a minus 4, that's 4, so difference is 4. Now looking at 4, difference is 4 is nothing, so that's going to be 2. And looking at 2, we don't have to look at 2 because that's too much. So we don't look at 2 anymore. Oh, we don't have to look at 2. That's true. Why do you look at 2? 4 is the only thing we're looking at. All right, now we go to 10. Again, 0 will be 1. 2 will be looking for 8. That's going to be 5. And looking at 8. And looking at 6 is 4. So 6, 4, so that'd be 3. And that's 6. That'd be 2. Now 6 again. Right, 6 to 10 is minus 4. So I'll go to look 10 minus 4, nothing. So that's going to be 2. Right? And then it's minus 4. There's a minus 2. There's also a 2. 6 to 6. Difference is 0. Difference is 0. Difference is 0. So we look at the previous 6. What is the difference? Previous 6, difference is 0 is 1. So now difference 0 becomes 2. Now 6 and 4. Difference is 2. So we'll go through 4. So that's going to be 3. That's it. Next one, 8. Default is 0, 1, right? Default is 0, 1. Again, 6. So difference is 2. The 6 difference is 2, that's going to be 4. And then there's a minus 2. Right, minus 2. 10 doesn't have minus 2. 8 or 6 with this 8, 8 with this 6, and 8 with this 6. we have to append it, because those are two different. We have to append it, right? And 8, 4, difference is 4. That's nothing. So will be 4. Length is 2. Okay, we're done. Now what? So with O(n) squared, we get all this, right? And then we have to go from every single one. And then we want to go from every single one, we start from 6, because that's the first likelihood we go. So we'll go 6. We look for anything as longer than 3. So we find 1. So that's going to compute with 1. Go to 8. 4. That's going to be 3. The 10. 10 is going to be a 1 and a 6. Yeah. And I go to 6 again. That's going to be a 1. Go to 8 again. Yeah, 8 is going to be a 3 and 3 because we have 2 4s. So the total will be 1 plus 3, that's 4, 5, 11, 12. I explode. What the hell? Because we're double counting. Dang it, we are double counting. Shoot. We're double counting, man. We're double counting. Yeah, with this 10, the difference is 2, it will be 5. How do we prevent double counting? Try it again, try it again. That's 1, so 8, right? 8. We know sequence ending at 8 with length is 2. It's going to be 4, right? But when we do this, we already know sequence ending at 6 with 3 is 3, right? So when I add myself, what is the contribution that I can get to involve me? Like only involve me. Because if we only have a value, that's not going to be valuable. So if only involving me, I don't know, previously we have 3, right? And only involve me. And then it has to be involve me 3 or 4. So that's actually 2, right? So involve me. So if it's anyone, yeah, so that's 2, 3, 4. So starting from 2, and I'm going to plus 1, plus 1, plus 1. So that's going to be what? Total number minus 1, right? So it's 3 minus 1, that's going to be 2. Right, that's going to be 2. So now go to 10. Go to 10, I look at 8, we have 4. So that's going to give us 3. And that also going to give us 1. 6 is going to give us 1. 8 is going to give us 3 and 3. Right? So involving me, so we have 4, previous 4. Right? So we can get 1, 2, 3, 1, 2, 3, 4, adding me. So we go 2, 3, 4. So that's 3. What does this give us? 1 plus 2 is 3. 3 plus 3 is 6, 7, 8. 8, 11. How is this 14? Still not right. Still not right. God. The 7 is correct. 7 is correct. I think the problem is the last 8. This one is the problem. This one's the problem. We go to 6. Oh, that's 3. Ah, that's 3. That's 1. That's 1 on 1. That's 1 on 1. So now we have 7, 8, 9. No, hold on. Because adding me giving 4. So previous was 3. Oh, I said 2 and 2. 2 and 2. So me, that's 3. So this, and this. So that's 2 and 2. 1 plus 2, so 6, 7, 8, 9, 10, 11, 12. We got 12. This starts to look promising. Like seriously, this starts to look promising. I see. So at each position, we go all the way front, and then we'll compute the difference. And then what we're asking is, at that position specifically, what's the length of the subsequence that has this difference? It's also ending here. And then based on that, I can compute what contribution this one can add. And after that, I compute the total. So here's how I'm thinking. So we're not going to do this. There's nothing probably in the length, so we're going to have this still. So what we're saying is we just want an array of array, right? An array of array is going to be, ooh, hold on. So we are at this position, right? And I call it, so it's a dictionary, array of dictionaries, right? The array of dictionaries. So what we're gonna have is, that's our memo. It's gonna be array, right? For this range, and each array is gonna be a dictionary, which we can call it default dict. It's gonna be a list, right? The list of a unique subsequence length at a certain distance. So that's that. So that's the memo. And we're going to start the first one, which is quite straightforward. And we're going to go with the second one. So the first one is do it by itself. And then we say, so we're going to do the first one. So we say memo 0, right? We already have a default dict. 0 dot append 1, right? That's that. And then what? Dot append 1. That's it. That's the first one. Now we say for I in range 1 to n, right? 1 to n. Okay. From 1 to n. So I grab my current value. I know my current value, so I know the. Now I have for j in range, right? For j. You know what? No. So we need to fix the first two. The first two we fix, because everybody else will only, they will not go to the first one because it's pointless. But the second one has to go to the first one. So memo 1 0 dot append 1, right? And how about we don't handle the 0 case, right? We said that for all the zeros, we will do it differently, right? We'll do all the zeros differently. But if we can have one solution for everybody, that would be fantastic. You know what? Let's keep it. Let's keep it for now. So that's the first. That's the second. And mammal 1, right? And oh, num's length. So therefore, we're going to say, right, if n is smaller than 3, let's return 0. There's nothing, right? Smaller than 3, there's nothing. We have to have at least 3. So this is going to be mammal. This is going to be nums 1 minus nums 0. That's the difference. And this is going to append 2. So ending at this with this. So that's the prep, right? The prep. And now this is going to start from 2 to n, right? And then j is going to be ranging from start 1 to j, right? It's from 1 to j, right? And every single one, we're going to compute a diff, right? So no, first of all, mammal I, its current position, and difference is 0, append 1. This is what we just have to do no matter what. Actually, this is going to happen here, right? Now for each one, so we can compute a diff. So the diff is going to be nums I minus nums j, right? That's the diff. Now we want to find out is, so we have the diff, right? We have the diff. So we're going to go to nums j, right? And see the length, right? The length. How do we find that? So we're going to say pre-length equal to mammal j, right? That's the position, mammal j, and the diff, right? Mammal j diff. Okay, hear me out. Hear me out. That's a list. Mind you, that is a list. So to go through the list, right? I'm going to go through the list. Okay, no. So what we're going to do is if diff, right, is not in mammal j. So difference has never been happened before. Now we're just straightforward. Mammal I diff append 2. 2 values, right? Else, if it is in it, then another for loop for pre-length in for pre-length in what? For pre-length in mammal I. No, mammal I, mammal j. Diff, right? And the result is 0, right? No. That's right. So now for the pre-length, the previous length, now I'm going to add myself to it, right? Add myself to it. So what do? So just the pre-length, if it's 2, that's going to just say less plus equal to pre-length minus 1, right? If it's 2, I can contribute to 1. If it's 3, I can contribute to this, right, and to this, and that's 2. We can contribute to 2, right? We contribute to 2. So the rest plus equal to pre-length, and when I say mammal, right? Mammal I diff dot append pre-length plus 1. It's adding myself, so pre-length plus 1. So we go through all this for each j, right? For each j. Now this is not j, this is I. So for each j, we go through all this, and we are computing the result along the way. Now once we're done, we just return the rest. All right, let's give it a shot. I hope this is a difficult question because this has been so long. And if this one doesn't work, then when I see the result, I see the solution. That's going to be 7. 7, 7, 7, 7, 7. That is going to be 16. Right? And then the one that I conjured up, 6 and 8, and 12. Right, so the nouns. What is this? This is going to be number of arithmetic slices. Nouns. All right, run it. All right, we almost. It's actually not almost. We have a lot to do. All right, first of all, we need to check the memory. No, I want to do this. I can say for n in number, for I n in number, for I n in numerate. Not just for n number, for n in number. Print n. I want to call it. All right, so do a 0, 1, 1, 2, and then 1. That's 6. All right, that's 6. Oh, I see. You have to go all the way to I. Okay, so this one pass. Not print anymore. All right, so this is not right. How would it not be right? I've never tried it, so let me give it a shot. Let's see. I'm very much hoping that this could be right. Zero distance, and then zero distance will be 1, right? And then it will be 2. You know what? I'm gonna write it out. If we can get this case also included, then we shall be good. And if we cannot, then we just simply consider it a different manner. All right, so we have 7, right? So first 7, position 0. We have the 0 is going to be 1. All right. Now the second 7, position 1, we by itself. So 1. Ah, I see. I see the problem. Hold on. What is the problem? The problem is by myself, right? Pre-length has to be. Hold on. What is the problem? Problem is pre-length plus 1, and add it to my thing, right? It's pre-length plus 1. Length plus 1. First of all, if pre-length is larger equal to 2, right? That's the only chance that we can have. Wait. So what, we just handle it differently? I don't know, man. So the next one, we find previous. What if I don't do it? What if I don't do it? Right? I don't do it. what if I don't do it? So I say I check with the previous one, result is 0. So I say the previous one is 1, then my 0 is going to be 2, right? Okay. What if I don't handle this one here? All right. And then I also don't do it here. I also don't do it here. So we say for this is going to be from 1. I'm going to check the previous one with the difference. I say if the difference is not in member J, then the difference append 2. If it is, then for pre-length, and this, otherwise normal I, current one, diff dot append this, right? Once we get out, I will say if 0 not in member I, diff, diff, 4, 3, and add 1, and then go here, right? 2, no 4, 2, 3, and 1, here, add 1, 3, 2. So 5, 4, 4, 3, 4, 3, 3, 2. So that's the total result. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. we count one more. How do we count one more? Right, when you use 7, that's 1. 7, 7, 7, right? Now this 7, which is here. And then we have this, so we have 1 and 2, so we have 2. It's related to this. Right, 7 and this. Like ending at 7, we have length of 3. But we also have these two, right? These two, because these are different. So we said 7, 7, and this 7. That's another 1. So that will give us 3. So we have this, and then this. Nope. This. Right? And then another 3 that's going here. So it's this. Right? And then we have this. Doesn't matter. Like this, we have this, and then we have this, and this. And then we have this, and this, right? So we have 4. Okay. What's the next one? So we have the 3, which is this, right? And then we have the 2, which is based on this. Which is this one. And why would it be not correct? right? And then this one will add. Oh no, we're already done with it. So we add the this is the last part, and then we added a 1 1. Ah, now confused. Let me do it one more time. Right, where am I? Where am I? I am at +1. Right? This is just -1 +1. And then, so we're good with 3 7. So 3 7 +1. Right? Now we add another 7. So now another 7. We have previous is 2. Right? So previous is previous here. Adding this with 3, and then we also have this is 2. So we add a new 7. So we say the previous 2, no, previous 3. Previous 3. 3, previous is 3. So we're gonna have this 3, right? And then one contribution is this much, and then this much. So again, +2. Yep. Then what? Then what previous has a 2, which is this and this. So we're going to contribute 1. Contribute 1. Okay. That's all the contributions I can give in the current step. And then I add a 3. Size is 0, 1, 0, 1, 2, 3. Size is 4, right? We have 4. And we're looking at this. Now the size 3. Now we're also looking at here. Oh, we have another one. Yeah. Size is also 3. So that's this, this, and this. Size is 3. And the last one is size is 2. Okay. Now we add the last one. So first of all, we're gonna have size 4. So 1, 2, 3, 4, 5. Right? And then my contribution can continue. So that will have 3 contributions. Right? Next one. 3, size 3. Size 3 will be starting from here. Size 3 means this, this, and this, right? That's size 3. So what we have is, we'll have to include this, and then skip this and then these two, right? And then the contribution will be this, this, and this. So we add 2. So we add 2. Now another 4. This 4 is also starting from here, but it's this. Ah, where does this 4 come from? I already handled. Oh, it's this, this, and this, right? Yeah, so it's this, 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 and this. Oh, now I see. Now I see the repetition. God. Yep, there is repetition. Which means this method is not going to work. We have repetition. Can we no, that will be that will be very unfortunate. God, I mean, it will work for the others, but it's not gonna work for this, and I can foresee there'll be cases that it won't work. So we're gonna give up. What the hell? Have repeats. No. Why will we have repeats? Why? Why do we have repeats? Well, what do we get? Right. What we get is ending at each position. I know the length. Actually, it's different length, right? So ending at this position, I know the different length. So I can compute based on the length. I have 5, get it, and then I have 4, we get it, and 4, like we can get all those. And that will all involve this, right? All involve this. Now if we go here, something involving this will be the same, right, as the previous one. How do we ignore it? How do we avoid double counting? How do we avoid double counting? How do we avoid double counting? And the thing is, I think this will happen in other situations as well. You have 3, right? How? This is different from previous, and now this one adding to it, right? And this one is adding to it. Any 3 counts? Are you saying we can only handle task is to avoid double counting. But we will have double counting unless we 1000. Are we gonna have something so big, like a giant? That's still not gonna work. We're gonna have like all possibilities. No. All right, I call quits. I call quits. I don't know. I don't know. I mean, I can see. You want to try? I mean, we can try. Assuming like, if this is the only problem that we have, I don't see this is the only problem that we have. I mean, I can just create a scenario, right? And then 2, 3, 4 is already computed, and then we'll be like 0, right? So in this case, we say like this, right? 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. When I add a 4, I can do this, and I can do this. The 2, 3, 4 is double count. Like we can give it a shot. Like simple. 1, 2, 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. Right? We can check the result. I think my solution won't work. 1, 1, 2, 3, 4. Shall return 5. But I think my solution might not work. Yep, double counted. See that? Double counted. Jeez. Why would we have a double counting? Because we are counting when we say adding 4, right? And we have 1, 2, 3, and we have 1, 2, 3, and we say 4. We're gonna do this and do this, and when we're adding this, we say 1, 2, 3, 4, and we do 2, 3, 4 again. That's when double counting happens. When it happens because at 3, I say with distance 1, we have 2 3s, right? It's two different. So when we add this, we say one of them, and the other one. And the other one, if we take the largest, it will always work. No. Alright, it's been 2 hours. It's time to call quits. Yeah, I don't know. No clue. No clue whatsoever. It's a hard problem, as expected. So now Friday is hard too. I think eventually they'll make every day hard. Nah, brute force is definitely not gonna work. And we know brute force is not going to work. Dynamic programming. All right. How do we handle the dynamic programming? All right. Let's see. We'll put this on nightmare. Yeah, it completely got us. Completely got us. Let's go for nightmare. Not my favorite. Jeez. It's not my favorite. It's a nightmare. Alright, let's see. I know it's dynamic programming, but how? The first or last element and a common difference. That's true. Starting from this point, we can easily figure out that one state representation that may work. It knows the number of arithmetic sequences that ends with AI, and its common difference is D. Okay, we are there. We are there. Let's try to find the state transitions based on the representation above. Assuming we want to append a new, we are there. That's what we have. We try to append a new one to the existing to form new. We can append AI to an existing only if the distance between the subsequence's last element and the AI is equal to subsequence. That's exactly what we have. Exactly what we have. We can define the state transition for the element AI intuitively for all j smaller than I. If I AI minus aj plus equal to fj ai minus aj as a total length. Yeah, we got that. That's what we have. We have this total length. A new arithmetic sequence. Set to 0, but how can we form a new arithmetic sequence if there are no existing? Weak arithmetic. Always form, yeah, that's what we do too. Keep arithmetic, no, it must be over, yeah. Number of weak arithmetic sequences that ends with AI and its common difference is D. And this plus equal to this plus 1. That's what we have. That's what we have. I think, I don't know. Appears here because of probably 1 from a new weak subsequence. The number of all weak arithmetic subsequences is the sum of all this. But how can we get a number of subsequences that are not weak? Count the number of pure weak directly. Equal to the number of pairs. Existing L is the new subsequence built with AI and AJ. We are appending new element to the existing subsequence. We are forming arithmetic subsequence. So, first part, number of new formed, and it can be added to the answer. Okay. That's the example I have. First element, no element, second one. Oh, we are there. The summation. But they are not using an array to represent this. Hold on, let's read it again. The number of weak arithmetic subsequences that ends, the total number. Hold on. The total number of subsequences. The total number of subsequences ending at D. Come on, switch your mind. Let's go, switch. We're gonna add them together, right? So let's go 7, 7, 7, 7, 7 again. So the first one, the difference is 0, and then we say the length is 1. Second one, the difference is 0, right? And the previous is 1, so it's going to be 2. And the third one, the difference is 0, and we have 3. And we say we keep adding. We keep adding. So that's a 3. And then we're going to say plus the previous, we're going to have 2. So the total subsequence is going to be, hold on, the number of subsequence. So number is still 1, right? We can add the previous one. So previous is 0. So add the previous, and number is 1. Now I can add the previous one, and the number is 1 and 2. So that's actually 2. So we have 2 subsequence with difference 0. With 3, and I have 2 subsequence, right? From this, I have 1 subsequence, so we have plus 1. So it's going to be 3 plus 2 plus 1. That's going to be 6. We have 6 subsequence because ending at 2, we have in total 2 subsequences, right? Which is this, right? This, that, 2. Are you sure it's 2? No, it's 3. It's 3. Because at 1 position, so I'm looking at the position 2, right? So